Okay, in this video, we're going to complete a graphic organizer based on the characteristics of a polynomial function. We're going to put all of this stuff together into one graphic organizer just to remind you how to find each piece. And notice I've already graphed it. I've already plotted and labeled these maximums and minimum points here. So let's go ahead and go through this. And the first thing it asks you for is what are the turning points? And those are the points that I have labeled there. The first one being negative 3.15, comma 3.08. And that is the highest point around. So we're going to call that is called a relative maximum. And then you have, it goes down, and at this point, that is the lowest point around, and it is located at negative 0.85, comma negative 3.08. And since it is the lowest point around, we call this a relative minimum. The intervals where your function is increasing and decreasing. Okay, first off, let's start off with increasing. Your graph is from left to right. We always read this, and we only use our x values. We're only going to use this x-axis when we're talking about increasing and decreasing intervals. Your graph increases till it gets to this point. That is this location right here. It increases everywhere from negative infinity up to the x value negative 3.18, and it's always an open interval. We never use brackets on this. Then it starts, at that point, it starts going downhill till it gets to this x value, which is right around in there, and it decreases from that negative 3.18 up to negative 0.85. Then at that x value, it starts increasing again, and from negative 0.85 to infinity, it is again constantly increasing. The domain for all polynomial functions will always be negative to positive infinity. There is never a domain restriction. However, sometimes you will have a range restriction, especially if it's a parabola. It'll have a low point. If it's an x to the fourth graph, it'll have a low point. Or if it's an x to the sixth graph, it might have low points or negative ones. However, with an x to the third, an x to the fifth, and x to the first, your range is going to be, again, negative to positive infinity. So all your odd degree functions will always have that as well. The parent function of this is f of x is equal to, take away all the multiplications, the numbers and all that, and you're left with x to the third. And again, the general shape of that is this. Now the end behavior, why are we labeling the parent function? The end behavior of this graph, because it has this parent function, will be identical to the end behavior of this graph. So here is our end behavior. As you travel to the right on your graph, as x approaches positive infinity, you're going uphill, just like in the x to the third. So therefore, y would be approaching positive infinity. As you travel to the left, you're going downhill, so y would approach negative infinity. Then finally, the zeros of this function, again, is simply where your function crosses the x-axis. A zero and an x-intercept is the exact same thing. In this function, because of its factors, the zeros of this function will be as x is equal to a negative 1, 2, 3, 4, a negative 2, and a 0.